Alright, welcome everyone to the Hydrautomat applications video. Here I'm going to be showing you all the different applications that the Hydrautomat could do. When I say applications, I mean uses for it. So all the different things you can do with the Hydrautomat are going to be in this video, or at least the ones that I can come up with. It turns out the Hydrautomat has a lot of different things you can do with it. You can do many things. We're going to get into all that right here. It's going to be absolutely incredible. So definitely watch this entire thing. If anyone doesn't know what the Hydrautomat is, I'm going to only go into it in brief. You can go and find the other videos and stuff on how it works and all this other stuff. But briefly, all the Hydrautomat is a self-powered water pump that uses air and water power to lift water to greater heights. That's what it does. So what we're going to do now is we're going to go into very first thing. Okay, so what we're going to do now is we're going to go into the first application of the Hydrautomat, which is what the Hydrautomat was originally built to do, and that is to raise water from a one point to a from one kind of a high water level to a higher, from one point to a higher point, basically, right? So I'm not going to go into the details on how this thing works or whatever. You can find another video on that one. I'll put up an annotation or a link to that just so we can save time and focus on the applications, because I want to be repeating everything in my videos all over the time. Every time I do this. So anyway, you have the high water mark here. You have the low water mark here. And just with this drop here or whatever, you can multiply this up like 2 or 3 different times, just with this, just with the original arrangement, like you see in the patent. Just with this arrangement here, you can actually multiply. Well, not multiply, but you can raise the water from this point here. Just by having some of it drop down to here, you raise some of the water here up into here. And main uses of this thing is you can use it for water storage, so you can pump the water up into a water storage tank. You can use it for agricultural and industrial uses as well. You also use it for residential and municipal reasons too. So I'm going to give you a list of some of the things. So for like agriculture, you could supply water for irrigation ditches and any kind of drip tape, any kind of irrigation out there. So many different forms out there. I think there's a lot of stuff that's coming to being in the past few years, especially. So you can basically water plants with it. You can supply water for animals. So you can see here's a little trough or whatever. You also have automatic water feeders and stuff like that for animals. You can use it to use it for utilities and stuff. You can wash with the water. You can have use it for any kind of utilities you might need it for. There's all kinds of stuff you can use water for, of course. Supply greenhouses, very much the same thing as for irrigation and stuff. Houses and whatever, you can if you have a cistern or water tower or something like that that's high enough. If you have a water tank that's high enough, you can just gravity feed the thing into a house or whatever, just because the water pressure falling from here is the equilibrium for the water that would be up in here would actually be about here. So this house here below has water that's at least always pressurized to some degree or another. So you can also do that too, is you can provide water for houses that's pressurized, so when you open up the faucet on the sink, it actually flows out. That's what another thing you can do with this, have a gravity-fed water supply. You can also use it for aquaponics systems, which is basically the same thing as irrigation, or not irrigation, but same thing as every time I say aquaponics, I forget about hydroponics, right? Yeah, you can use it for hydroponics. You can use it for aquaponics. You can use Hydrautomat for all kinds of different things like that. Aquaponics is pretty interesting. Yeah. I won't even get into that, but so you can also do cisterns and things of that nature. So basically, it's mainly domestic industrial, maybe not so much industrial. You can use it for cooling and stuff like that. You know, supplying water for cooling and stuff like that. It's primarily agricultural and you know, kind of small scale stuff you can do with the Hydrautomat as it is. And you can also create you can stage this thing too. You can have more mold. Yeah, sorry folks. You can have more than one Hydrautomat connected to another in order to get even higher, even greater heights out of this thing. So that's another thing you can do with this device. So we're going to pause this video and go on to the next one. Okay, now another application for the Hydrautomat is actually the ability to pump different fluids with it. So you can actually, even though it's originally designed to just pump water for irrigation, things like that, you actually use it to pump things like hydraulic fluid and even gases and stuff too, if you get a hydraulic cylinder or something like that to separate out the two different fluids. So you can keep the if you can keep the operating tank separate, if you keep the air in the operating tank separate from whatever fluid you're pumping, you can actually use the action of the Hydrautomat to pump different whatever fluid you want to. It could be a gas, it could be a vapor, it could be a liquid, you know, it'd be some, you know, even a thicker liquid like oil, you know, something like that. You can actually pump with this device. Very interesting. So I'm going to show right here on the screencast here. You can see here it says pneumatic cylinder or whatever. That's what I'm talking about. So basically this is a piston or something like that. And what this acts to do is this can actually this helps separate the fluid in you know, the pumping tank and the communicating hose right here. Oh, by the way, this right here isn't directly connected to this at all. This is just, you know, they're just intersecting, but they're not, you know, the air in here is not touching the air in here. This is just, you know, this is separate from here, just to let you know. Anyway, as long as the gas or whatever you're dealing with right here is separate from what's in here, you won't have to worry about something like ammonia or, you know, refrigerant or whatever like that, you know, seeping down into this hose here and interacting with the water, because it can, one, contaminate the water when the thing goes back out into the river, and two, you're going to lose your whatever you're trying to pump with it, because, you know, provided it's not like air or something like that. You know, if you're pumping, say, you know, alcohol, ammonia, freon, even fluids and stuff, you know, knock on wood that they actually come through this thing or whatever, but you know, if you get this thing, if you get the proportions and stuff right, there's no way this thing's going to be coming up through here unless something really disrupt the architecture of this thing. But as long as this is calculated out, you're not going to have a fluid or something come up through here. But as for a gas, yeah, you can have a potential mixing like ammonia or something would come up through here. If this hydraulic cylinder wasn't here, you could have ammonia seep up into here, mix in with the water, and create ammonium hydroxide, or household ammonia as it's also called, and that would get out into the groundwater and would be useful. It wouldn't be good for the earth either. So that's why this right here would be very useful to have. So if you're dealing with air or something like that you want to pump, you know, you can get a cylinder, and when this thing, you know, pressurizes, it just pushes the cylinder here, cylinder pushes the air in here, and that pushes, you know, whatever's in here out. And then when this thing drains out through the siphon or whatever, when this thing water drains out, then, you know, the air, you know, sucks on here, and then it pulls, you know, a cylinder from, you know, here to here, and then it pulls the air or whatever subsequently, you know, up into here. And then when you have that vacuum, what happens is, you know, this check valve closes, and then the only place it has to pull from, aside from inside the tank, is, you know, the inlet. So then it'll just pump the stuff in here, and then on the pressure phase it pushes out, and pushes out through here. Pretty interesting. And you could pump all kinds of stuff with it. I mean, you might even be able to pump hazardous materials with it, whatever. I mean, as long as you have something to separate it, you don't have to worry about it getting into that. And as long as, of course, everything is, you know, made to spec to handle whatever it is that you're handling. most of all. But as far as the Hydrautomat itself goes, you don't have to, all you would need is something like this to separate out any kind of gas or whatever from getting into the operating tank. So anyway, with this setup here, you can pump oil or whatever you want to with the Hydrautomat. So anyway, let's see. Yep, pump other fluids. Oh yeah, the intensification. I don't think I wrote this down in here. But also with this device, you can take advantage of the hydraulic multiplication of force with this thing. So as you can see here, this pumping tank is, it's probably like a third to a fourth the size of this operating tank, right? Well, when this operating tank fills up, from here to here, say there's like, I don't know, this drop here from the water falling into this operating tank here. Say that, the pressure of the water falling there generates pressure like, I don't know, 5 psi. Of course, this thing is incremental and eventually stabilize and stuff, so it's actually very dynamic, but along with the fact it's an open tube. But just say, for example, we got 10 psi. That's an easier number to work with here. So there's 10 psi in this operating tank, right? And say that this thing is 1/10, even though it's like a third or a fourth the size of this thing. But say this thing is 1/10 the size of this, right? So there's 10 psi in this tank, and this is 1/10 the size of this tank, right? Well, provide if the hydraulic cylinder, if the pneumatic cylinders dimensions and stuff are correct with these two or whatever, that's all calculated out. Or let's just forget this for a moment here, and just say there's directly a hose connecting to this tank, right? If you have 10 psi going in through this right here, and this is 10 times bigger than this, what will happen is that the pressure that's exacted upon this tank here will actually be 10 times the amount, because this is 10 times as big, so it'll be 10 times the amount of pressure exacted on here. So it'll be 100 psi in this tank right here. Pressure will be at 100 psi, and here it'll only be about 10. That's called hydraulic intensification. So if you need high pressure for whatever reason, you can just have something like that, where you have just a gravity-fed system generating a relatively lower pressure. But since there's such a high volume, what happens is that when that pushes on a smaller tank that's smaller than it, you actually have a ratio there, and you actually intensify the amount of pressure on the thing. So you can create much higher pressures with just the same amount of starting pressure through basic hydraulics. Basic pneumatics is another thing you can do with a Hydrautomat to help pump things even higher, or do whatever it is you want to do with it. Run a pump station or whatever you want to do with this thing. So that's another interesting application for it. Third really interesting part is that if you pumped something like Freon or some kind of refrigerant through here, and had a compression fitting, and had a compression valve or something like that, an expansion valve, basic what is it, basic refrigeration stuff. You can create heat and cold, right, through vapor compression refrigeration, and also vapor compression heating, and you create heat and cold from it. Well, what you can do with that is you can create two things. You can use it to distillate water and stuff, like is seen here. But what you can also do is you can create what's called a you can also freeze things with it too. So you can use it for refrigeration, inland, when you're use it for domestic and industrial and commercial, industrial uses as well. For refrigeration, commercial refrigeration, you can use it for. But this interesting little thing I found here on Rex Research is what's called an ice wall, or an ice dam. And basically what you do is you just run the refrigeration coils into the water, in like an ocean or something, and you can create a temporary dam made out of ice with this thing. And in 1932, I think they were planning on doing this, but as most of us know, World War II was coming up, and I'm pretty sure the Germans didn't want to go through with this project because this was supposed to be in Germany, right there on the border of Denmark, with Denmark and the what is it, North Sea here or whatever. That didn't go through because you had World War II and stuff, and also they're invading Poland and stuff. They didn't want this thing to get sabotaged, and that, you know, a little bit of land would have detracted away from the war effort, I'm sure. But anyway, this device here can create temporary ice dams, and that can be used in civil engineering for, you know, building stuff, you know, for, you know, temporary structures for all kinds of things. In this case, it was to reclaim, you know, previously submerged land and stuff like that. They also wanted to use a dredge or something and pump, you know, the seafloor into the other side of the dam or whatever, so that you could just, you know, fill this thing up with new land and stuff and use it for agriculture or whatever they wanted to use it for. But anyway, you know, realistically, what we can do here in, you know, like New Jersey, for example, is we use these ice dams for, you know, some kind of hurricane defense, you know, barrier, so that, you know, so that we could have something like this resist like storm surge or whatever. So instead of just having, you know, the, you know, say you have like the barrier islands here, and you have, you know, the ocean, you know, in this area, you know, instead of having just a storm surge, you know, come up straight into the, you know, run up across the beach and destroy houses and whatever, you could also have a, you know, sort of ice dam or whatever, so that when the water comes across it, you know, you have a major break, you have something to break all that force and whatever. You know, that giant ice dam can, you know, break a lot of the force. And also when it rolls over, it kind of creates an eddy current or whatever. And that can also help to divert the energy that would otherwise go up on shore. You know, that's kind of my theory. Maybe I'm wrong there in some ways. You know, I probably am, but, you know, having a, with the circulation thing, I'm probably wrong or something like that. But having a barrier like that, you know, against storms, or, you know, use it for civil engineering or something like that, is also another advantageous thing you could do with something like the Hydrautomat, because the Hydrautomat, you can run the thing 24/7, doesn't cost much to run. You know, it's really just maintenance and stuff. You could, you know, use it for whatever you need to. I mean, say something gets flooded or whatever, you can use, you know, create an ice dam, because you can turn, you know, what otherwise would be, you know, just water coming in and helping to flood things even more. You could just, you know, possibly come up with, you know, some kind of drag and drop refrigeration coil, you know, not necessarily powered by the Hydrautomat in that case, because Hydrautomat's not very portable. But, you know, also you could use this ice dam, you know, for like, you know, broken levees and stuff too. So you could have maybe a generator or something like that by Army Corps of Engineers or something, you know, come and use something like this. There's a few things you can use this for. But, you know, as a defense against hurricanes and stuff here in New Jersey at least, you know, you could definitely hook this up to like a more permanent Hydrautomat, you know, deployed on the coast, or, you know, barrier, you know, in like Barnegat Bay or something. You can stick a Hydrautomat there and power something like this with that device. You know, provided the device has enough, you know, pressure going through it. You could, you know, use it for, you know, whatever. So that's another neat little, you know, tidbit there. Oh, and following up on the ice wall and stuff like that, another thing that's doable with the ice wall, which is actually being proposed right now, is over in for the Fukushima Daiichi nuclear power plant over in Japan. They're actually proposing to put up one of these ice walls right there. You know, of course they want to have, you know, they're probably going to be powering it, you know, off the grid or something like that. But this thing is going to be used for a kind of a sarcophagus or something like that, to try and encase this ring of nuclear reactors at the Fukushima Daiichi plant. So all the reactors that are leaking right now, what they want to do is they want to surround it with a perimeter of refrigeration coils and whatever. They'll, you know, go down into the ground, and what they'll do is they'll entomb this thing with ice, so it'll prevent all the groundwater from washing down into the aquifer and then washing, you know, through all this contaminated ground here and then taking out into the ocean. You know, I hope they, you know, get this thing done very quickly, because it just keeps on leaking all the time. But anyway, this is one thing that's been proposed, and is a pretty good idea. So that's another thing you can do with an ice wall, is you can have it as a safeguard against nuclear reactors leaking, or at least with the groundwater carrying away any contaminated soil or something like that. So that's another thing you can do with it, is use it as a sort of safeguard against the more likely doomsday scenario out there, instead of a nuclear war having nuclear reactors go off. Maybe even put an ice wall around these damn storage tanks. But anyway, aside from the whole nuclear thing, that's another thing you can do with the ice wall. You could also deploy an ice wall, for like dams and stuff, dealing with waterways and whatever. So, whatever reason, if you wanted to dam something up temporarily with ice, instead of having to build this giant, wall or something like that, you could just have some refrigeration coils run and, do that. So if you want to make a new hydroelectric dam or something, you can do that too. Okay, so one of the larger scale things that can be done with the Hydrautomat, namely with structures that already exist, like hydroelectric dams or whatever, or maybe even a waterfall or something like that, you can do this with. Is you can this is mainly for hydroelectric dams that are already in existence, not so much waterfall, but any kind of drop or decent sized slope or whatever. You can actually use this to assist the. This is kind of like an auxiliary power unit. You can use the Hydrautomat as kind of an auxiliary power device. A device that can help bring some secondary type of power, secondary source of power to a already existing hydroelectric dam. So as you can see here, this yellow bar would be the dam itself. This structure here would be the turbine, and this would be the low water mark, I guess you can call, and this would be the high water mark. So this right here is where everything would be dammed up, and this would be the other end of the dam where there's really not much water or whatever. This would be the inlet, this would be the outlet. And this is kind of like an entrance to that. So anyway, kind of oversimplified the Hydrautomat. I just put a gray bar down instead of having all the tanks and stuff drawn out. So you can see the one tank here at the top of the reservoir or whatever. So it kind of looks like a water tower more than anything. And the way this works is the same way as every other all the other conventional Hydrautomats work. This is basically a traditional Hydrautomat, but it's just really tall. So what this thing will do is it'll take in the water through sort of intake port. I would prefer the Hydrautomat actually being on the other side here, so you can easily access and maintain it, because it that wouldn't be partly submerged in water. But I decided to draw it here, at the time. But anyway, water would go through the Hydrautomat. It'd eventually get pumped up through the different tanks and stuff up into the reservoir here, into this container at the top, and then would fall down this auxiliary tube here into the turbine. And the point of this is that so you get say this is about, see the distance here, the pressure that'd be generated from this fall here would be about I don't know, 100 psi, which is not anywhere close. It's probably like 10,000 psi or more. Maybe in the millions. I have no idea what say like the Hoover Dam would generate. But anyway, for example here, say this is like 100 psi, that this would generate. Well, imagine you got a normal Hydrautomat where you have two pairs of open and closed tanks. So you got an open tank here, you have a closed tank here, have another open tank here, have another closed tank here, and then you have your feed tank and operating tank. So you would basically be lifting it like 3 times. So this this distance here would be you'd be lifting water for up this distance here on the first stage, and on this distance on the second pair of tanks or whatever. So this, all in all, this would be about 3 times as high as what it originally was. So you got 1 time, 2 times, 3 times as high, and theoretically you'd have 3 times the amount of power or whatever coming out of it. So instead of having 100 psi, you'd have about 300 psi. Maybe I'm wrong with the hydraulic calculations. Haven't taken hydraulics, so I can't tell you. But just for an example here, give you an idea. Say it's like 3 times as much, so it's 300 psi instead of 100. So say the turbine's limit is like 150, and it's only going at 100 because maybe the water level's low, like it is over in Lake Pontchartrain for the Hoover Dam. Say it's only it's only running 2/3 the amount of power. Well, with the Hydrautomat, if you had something like this, to lift it up, the kind of default, 3 times as high, ratio or whatever, you could actually power 2 entire structures at full capacity. So 150 psi limit here, another 150 psi limit here, makes 300 total, and that'd be supplied by 300 psi pressure being generated by this the fall from the reservoir tower down to the turbine. So you could power twice as much if this thing was running at 2/3 capacity, or if this thing was like running at full capacity right now. You could have 3 of these things, powered, something like that. And that's one application you could have with a Hydrautomat, is you could use it as a auxiliary structure to increase the output of a power station like this, out of a hydroelectric dam. You increase the output by 3 times as much, just with the normal thing alone. And if you selectively control which tanks can have pressure and suction applied to them, you could have like 10 or 12 or how many pairs of these things up in the air, just going to ever greater heights. And even though you could have a setup that would only allow you to run like say 2 pairs of these, only run like 2 open tanks, only run 2 closed tanks. So say this is like the default arrangement where the operating tank can only power 2 tanks at a time, and you have like 10 of them. Well, you can not run 8 of these things and just slowly carry the water up tank by tank. So say that these tanks are in service now, and then you want to get this up to a higher one, but you have say there's a second pair up here, say there's a third closed tank here, right? And you want to power that close. You want to have the operating tank, create a vacuum that can suck this water up into this, third closed tank. But these guys already would overload this thing, so you won't get any real power out of it. But what you can do is you can turn off the closed tank here in the bottom, so that only this closed tank and this closed tank here, imaginary one right now, would be running. So these 2 would be pumping, and this one wouldn't be running, and you just like shuttle it up that way. So you could turn off the ones on the bottom, and then turn on the ones at the top, and just slowly, piece by piece, step it up, just by turning off, by closing off the air supply to certain tanks. So that's another thing you can do with this thing. You just take it to a really large distance just by controlling which tanks have power to them. So that's another really interesting thing you can do with the Hydrautomat. All right, now we're going to move on to some more varied versions of the Hydrautomat. Things that are quite a bit more out of context with the original patent. And this one right here is a coastal or more maritime version of the Hydrautomat, which means that it's meant to operate around the coast and wherever there's waves. You can do it in the Great Lakes or anywhere where you have enough have a large enough body of water that you usually get some decent sized waves out of the you can get some decent sized waves to power the Hydrautomat. So basically this thing is a wave powered Hydrautomat, and the way this thing works is, as you can see right here, we have the operating tank. And in the operating tank, you can tell there's no feed tank on the top. There's no siphon coming out of it or anything like that. And that's because it doesn't actually need one at all. Instead, what it uses is just uses the power of the waves to push it up and down, because what'll happen is you'll have the operating tank is actually modified. So instead of having a closed container where you have a few openings in it, you have like one bulkhead at the top and two at the bottom. And instead, what you have is you just have a open body container, open bottom container, so that this right here is just open to the ocean or whatever, and the water can penetrate through, without any problem. There's no barrier or anything right there. That's just the rim of the container in this case. I should specify that more, but that's all this is right here. There's no wall or anything there. So the water can just freely flow up and down into this container here. And, this is the rest of the container. This is the actual wall. And then it has a tube or whatever coming out the top. So anyway, the way this thing works is that the motion of the waves pushes this, air pocket here, this closed air pocket in the space, pushes it up and down. So when the waves recede and when they go down, what will happen is they'll pull the air down along with it. And when it pulls the air down along with it, what will happen is it'll create a partial vacuum, especially over here where it's pulling the air, into itself. And then when it evacuates itself, hold on a sec. Alright, so anyway, what will happen is when the waves kind of are on the receding phase or whatever, when the waves are going down, what will happen is that there'll be a partial vacuum that'll be created here in the pumping tank, and that vacuum will actually pull water up from the ocean here past this check valve and up through this tube here into itself. And what will happen is when the waves then go on to the next phase, when you have have the peak of the wave go by and pushes this thing up, what will happen is that this thing will get compressed. It'll compress the air inside of it, and then it'll just push the air up into itself right here, and the pressurized air will push upon the water, and then what will happen is it'll push down on this pipe, turn off this check valve here. Check valve will automatically close, and then what will happen is the water will have no other place to go. Since it's pressurized, have no other place to go but through this other tube here that leads out to a water tower and has another check valve too on it. And then the cycle begins again, because peak of wave eventually will pass, and then it'll start to go down again. And when it goes down again, the cycle repeats all over again. And during the vacuum phase, this thing closes off. So when it's pulling up, this will close, and only this will be allowed to open up. So basically, it's just a reciprocating pump that you can make out of the ocean on the cheap. So anyway, this is how the whole device works. It's basically a reciprocating pump, but with the exception of the check valves, absolutely nothing on here is mechanical, which is really good, because the fewer moving parts that you have, the less things are going to break down and wear out and things of that nature. So that's what's really good about the Hydrautomat. So that's the end of this right here. If you're wondering why there's an application to pump seawater, I'm going to get to quite a few in a minute. But right now, you can, as it is or whatever, you could, power a turbine or something like that. You could just raise this up by gravity and raise it to even greater heights, by connecting it to, other tanks. Just have a normal Hydrautomat or whatever, just with a modified operating tank and different place to tap into for the input or whatever for water. Instead of having this thing connected to a feed tank, you have it connected to the ocean. And yeah, so you can power something with that right there. Just by force of gravity. This much of head here. And yeah, so that's for this part here. Okay, now we're going to go on to the solar gradient pond, and thankfully a whole bunch of software issues have been worked out, very thankfully. So anyway, we're going to go on now to the other application of this Hydrautomat, and as you can see here, I have a full-blown illustration of it with all the colors and nice things to it. And basically, what you can do with the Hydrautomat is you can use it, use that coastal configuration that you can see right here. So you see how, I think I explained in a previous clip or whatever. I think I'll have to go back just in case things get all messed up. But anyway, just in case they did, I've had issues with these screen recorders and webcam things. But anyway, this operating tank here and stuff, have this coastal thing where it's powered by the waves and stuff, pumps water upward and stuff, and instead of just simply putting it into a water tank or whatever right here, so instead of just pumping the water up into here like this Hydrautomat is doing, what you can do is you can have this awesome looking thing right here, and what you can do is you can pump that into the water tower here, but the water tower, instead of just sitting there for whatever reason, can actually fuel what's called a solar gradient pond. And I'm gonna have to explain this all over again because my last video got annihilated. What will happen is that the solar gradient pond, the way this device works, is that you have a container, or with a solar gradient pond, usually they just dig a giant pit or something, line the thing with like polyurethane or whatever, fill the thing up with salt water, and then they just let it bake there in the sun. And what will happen is we'll have two layers of stuff. They'll fill it with salt water on the bottom, like you can see right here. You see my cursor? This would be the salt water and the brine, this dark blue here with the white speckles or whatever. This, I'm going to zoom in. Can't believe control zoom in doesn't work. This right here would be the brine or salt water right here, as you can see. And it's called the non-convective layer. And I'll get to that in a second. But the second layer here is a layer of fresh water or distillated water, and that's called the convective layer. Now, what happens is when gotta learn how to work this program. Anyway, what'll happen is, say there's like a sun or something like here, right? And the sun's beating down on this. What'll happen is that the sunlight will penetrate through this layer of fresh water here because it's transparent. And what it'll do is it'll hit this salt saturated brine or seawater here, and it'll start to cause it to take on heat. Now the brine seawater, it's more dense and stuff. It's got a lot of salt content, so it takes on it stores the salt content more. It stores the heat more than fresh water would, because fresh water is very transparent, so it'll just let it pass through a lot of the time. But the salt water will actually store the heat a lot more. It's kind of like heating oil or something. It just keeps the heat in more. And that's one thing that this will do. And also, it says non-convective here. What happens is that since there's so much salt in the brine and or the salt or seawater here, brine, if nobody knows what brine is basically salt water, but it has a lot more salt in it than normal salt water like you find in the ocean would have. So it's called brine. That's what brine is. So anyway, there's so much salt content in this water that convection can't really take place. So convection is basically where the hot, like a hot version part of the fluid will like to rise and the cold part will like to sink. So, you'll have a kind of a cyclic action or whatever. Well, the thing is that with brine or whatever, it's so heavy that convection doesn't really take place at all. It just sits there. It'll just sit there and it'll bake. So there's not going to be much movement. There's not going to be much heat being exchanged and stuff. It's just going to sit there and get baked by the sun. So anyway, this convective layer here or whatever will just sit there and bake. And I'm not even going to bother to work the article or whatever. But I think there was a report or something like that of the temperature or whatever being like 92 degrees or something like that, Fahrenheit, and some test site or something like that in Israel where they're testing this stuff. And they got it was 92 degree day, and they had like 180 or 190 something degrees Fahrenheit inside the pond. So like say the air temperature is like 92 degrees, or 82 or something like that. This thing was actually running at like 192 at the highest. It was 192 at the highest, and I think it's like 80 or 90 degrees outside. So that's how much this thing can heat up and stuff, and that's quite a decent amount of heat there. And this was just with a gradient pond, right? That's when I say gradient pond, I mean the traditional version where they just have a pit and it's all open to the air and stuff like that. But with this device here, I think it's a bit different. But first, I want to go over everything. Okay, so I've pretty much gone over that part. And the way this thing, actually, the purpose of this is that usually a solar gradient pond is used to generate power. So what they'll do is they'll take a coil or something like that, and they'll run refrigerant through it. So they put a coil here in the brine that gets heated up, and you run a refrigerant like Freon or ammonia or something like that, and it just you pump it through here, and as it goes through it, heats up and expands. And what'll happen is the expansion will cause the stuff to gain a lot of pressure and stuff, because when it expands out and whatever, and it's in a closed area, it'll gain, the pressure becomes higher or whatever, and that pressure can then be fed to a sort of, it's kind of like a variant of a steam turbine. It's like a customized steam turbine they were talking about to handle refrigerant instead of steam, and they send it to a turbine, which then turns a generator, that generates electricity, and then when the refrigerant is done doing what it's doing, you just put it through a condenser, and in this case you just run this thing into the sea or whatever. So with this coastal hydrotomat thing or whatever, you also have the cold water of the sea to help condense this thing down. They go back into a liquid form and then just pump it back up into the heated solar gradient pond all over again. Now there's two other things you can actually do with a solar gradient pond. One is you can collect the evaporated water, and because what happens is the thing heats up, so you can just contain this thing within a closed container, which is what I really believe in doing, rather than just having this thing sit in an open pit, like a lagoon or something. Have an actual controlled facility to house this darn thing, controlled device like this little tank here. And then what you can do is just have this condensation gather up in here, have a condenser, which is another coil with just have salt water coming from this reservoir that's just pumps up cold water, run the cold water through this little condenser coil here, and just carries the heat away and dumps it back into the ocean. So you just take up ocean water, and all it does is it heats up a little bit. So anyway, what this will do is the water vapor will touch this cold coil, and it'll start to condense and just go from gas form or vapor form into a liquid form, and you just have it run down a little tube or whatever into a storage tank, and you have then you have distillated water. And distilled water is actually very useful because you can use it for utilities and things like that. Distilled water actually has a few industrial and other utilizations for it as well. You can also mix the stuff with minerals and trace minerals and things like that, and make drinking water out of it. So you can have water that's good to drink, from this what would otherwise be brackish or salty water. Instead of having salt water, you can turn it into something that's actually drinkable, and that can help to alleviate the world water crisis that we're going through. So there's that one leg of the three things you can do with a solar gradient pond. So you can create electricity with it, you can create drinking water or utility water at least with it. You can also use this water here to replenish this convective layer to help keep on the heat, because what happens is when this lays on top here, it helps keep the heat from directly, keeps the convective layer. I forgot to tell you guys, this convective layer here also prevents the brine or whatever from directly contacting the air and radiating off heat or whatever. Because even though this is not convective, this air definitely is, and that can, you know, contact the outside here and help radiate the heat out, and that's not good. Or in an open pit design, what happens is this would directly contact the air, which might also be exposed to the wind, and the wind could just blow cold air across this thing and cool this down real good. So that's another reason why they have a fresh water layer on here. Although with a closed, you know, tank or something, you don't so much need this. Either way, you can always, you know, take this and replenish this layer with it. So there's that. Now anyway, the third version of this thing, you know, third thing you can do with this is that you can discharge. Is that when this is too salty, instead of just letting this evaporate off and you're left with a giant salt block here, what you can do is, you know, either pump the salt, this brinish, this, you know, very well heated, very salty water here. You can pump this out into the sea, like, you know, through this pipe here. Or what you can do is you can run it through a heat exchanger, preheat the incoming water here so that the incoming water isn't as cold and doesn't take as long to heat up. You know, so that it's already preheated and it's ready to go. You know, and heat up, you know, this, you know, does its job faster. As well as the fact that you can send this thing to an evaporator, which is dedicated for the purpose of, you know, evaporating off all the remaining water. And then you could just be left with a salt layer in this trough here. And once the salt water is all evaporated off in this thing, you can just take the salt out of it and you know, contain it and, you know, use it for whatever. So that's one thing you can do with this device as well, is you can run it through a preheater, or you can run this through a preheater and directly into the ocean if you don't want to do it to here, whatever. But also this device, you know, this is basically, if you're wondering what this is basically like a solar concentrator or whatever. You know, you could run this through a tube that could be at the focal point of this concentrator. You could do that, you know, have a you know, glass tube or something that's transparent. Or you could just let it sit here and bake, you know, whatever you want to do. But, you know, preferably have, you know, this thing in the shape of a trough or whatever, so you have this bent piece here, and then going laterally, you know, this way or whatever, you know, not upwards, but, you know, lengthwise, because this is 3D here, but lengthwise have a trough or something like that. And then when this is all dried up, you can, you know, vibrate this or whatever, shake the salt loose, and then just, you know, pour it like a trough into a, you know, container. And you can sell the salt for salting roads. You can use it for food, you know, because salt is, you know, good for, you know, your health and stuff. Especially in like a developing country and stuff, you know, they might need, you know, diet, you know, salt's a dietary supplement or whatever, you know, might need that. I don't know. Just, you know, giving out, just brainstorming here. So that's another thing you can do with this device here. So that's what you can do with the solar gradient pond. You can generate electricity. You can generate, you know, distillated water, and if you mix it with, you know, the right minerals and stuff, you can make drinking water with it. And you can also, you know, make salt with it. So in an area where you have rain and stuff, you can do that as well. And another thing that you can do, fourth thing that's not illustrated here, is that this heated refrigerant, before you run it to a turbine, or after you run it to a turbine, whatever, you know, you can do both. What you can do with this thing is that you can run this refrigerant, this hot refrigerant here, to the evaporator. So what will happen is that as the salt water goes through here, you're going to take this really hot refrigerant, you know, pass it through a heat exchanger here in this evaporator, and that can heat this thing up even more. So instead of just having to rely upon the sun to heat up, to evaporate this off, you could run this, you know, super hot stuff through here and evaporate it in no time flat, right? You could do that too with this device here. And another thing you can do is, you know, this, you know, waste tube here, you could actually make this more economical by taking this and running it through a heat exchanger here before you run it to the ocean, because this waste heat here is still heat, and you could preheat this, or you could also alternatively run this through a heat exchanger here and preheat this cold water so that this heats up faster too. That you can also do. So, you know, positive feedback is always a good thing, as long as it's properly regulated. So Yeah, that's another interesting thing you can do with this whole device. So I'm going to pause this now, and I'm going to go on to the next thing. All right, now I'm going to go to some more, I wouldn't say advanced parts of the Hydrautomat, but you know, some things that are a bit more sophisticated or whatever. At least haven't been discussed very much, or maybe they just weren't illustrated in some of the original news articles and stuff that I can find about the Hydrautomat. So anyway, here's one of the most basic things that like we thought of, and that's to take the top part of one Hydrautomat here. So you have the feed tank, and you have the two closed containers, two open containers, and the operating tank or whatever. And as the water gets pumped up into the higher tanks or whatever, eventually you're going to come to a point that's at it can go as far, it's basically reach the limit of the operating tank. Just this whole arrangement here, it can't pump any higher to like say this point, for example. Although you could take this thing a few orders higher and stuff. It all depends on the dimensions. Everything is relative with this device, so it's really up to you what you want to do. And whatever your setup is. But anyway, say this here is the top, right? So what you can do with this thing in order to extend it is you could actually take this tank here and use this either as another feed tank, or you could run it to another dedicated feed tank here. And then this feed tank can feed into another operating tank, a second one, which as you can see right here, it's above the high water mark. So this would be the new high water mark instead of the high water mark being this dotted line here. And the low water mark is still going to be the low water mark, right? So instead of having just this here, this distance here determining the pressure for the most part, and this distance right here determining the suction, you have this distance right here determining the suction, and this distance determining the pressure right here. And that's what you can do. That's basically gives you a lot more push and pull, and you can allow you to lift the water to greater heights than you would with a smaller arrangement or whatever. Of course, it's going to take a bit more time and stuff, for it to pump up here and to replenish this and stuff. But at least with this right here, now you can, instead of pumping it to here, you can actually pump it to here or whatever. And this is only, as you can see, this has like two pairs of open and closed tanks. And this, like one pair here and one pair here. Anyway, you can have a, this has only two pairs here and this has only one. Well, you can actually add on a second pair, and this thing is basically going to be like twice the height of this thing right here, or at least as it's shown here on the illustration. So, if you link two Hydrautomats together, you can actually have, instead of lifting it to just instead of lifting this up like 2 or 3 times the distance of what this head would be for the normal Hydrautomat, because this right here is the head, and the Hydrautomat usually lifts it to like 2 or 3 times that or whatever. It all depends on whatever the distance is. Usually it's like 1 and like 2 times or something like that. Depends on what you want to do. It depends on the size. But you have, say you have this, for example, and that's like 2 or 3 times, and this right here can easily be like twice this. So that's kind of the power of this thing. It can lift up many orders higher than what this thing could do here, just by linking one Hydrautomat to another Hydrautomat. And as you can see, you can lift up to something really high, like maybe a water tower, for example. It won't take much. I just have a little bit of the proper amount of head or whatever, and you can take this thing way up. It all depends on what the settings are and all that other stuff. That's one thing you can do with the Hydrautomat for just about anything, even in a coastal arrangement. On the coast and stuff, instead of just having this feed tank and operating tank and the siphon and stuff, you just have the coastal Hydrautomat, with that open body container or whatever, just pumping up this one line here, and they can just pump seawater from the ocean and stuff. and pump this, to its maximum height. And then when it gets to the greatest height, then you can take this right here and then run it to either a conventional conventional operating tank like this right here, or you could run it to kind of a hybrid or just another operating tank that's dedicated to that or something like that. Whatever. You could have a different operating tank powering, a tank here, powering this right here, and this would suck up the water collected from here and stuff and pull it up, and whatever you want to do. I mean, there's many different ways you can tweak this thing, and I would definitely recommend experimenting to find the most optimal arrangement as well. So that's for the multiple Hydrautomat here. Okay, so a lot of you at this point might be thinking, okay, well, this thing only runs on water, right? And it's only applicable in places where you have, like, not just only where you have water, where you only have water on like a slope or a hill, a slope hill, or a slope or a dam, or you could use this thing over by the ocean or something like that. But unless you have like a difference in elevation, right, this Hydrautomat can't be there, right? It can't exist. It can't. Well, you can exist, but it can't work. Well, actually, there's a few interesting things I came across. One thing I was trying to create after it got really cold and I was getting frostbite working on this thing, working on the Hydrautomat back in November or whatever, I decided to try and create a Hydrautomat that ran on heat or cold or something like that, right? So you have a thermal Hydrautomat like out in the middle of the desert or something that runs in a closed loop. It just heats up and cools down to create that pressure lift, which you can easily do by filling up you could take the operating tank, for example. Well, I really didn't zoom in now, did it? Hold on a second. There we go. With Linux, for some reason, it's very hard to try and get this thing just right. Anyway, what you can do with the Hydrautomat for a thermal version is that you can say you have this here as the operating tank or whatever. So instead of having water go up into this thing here, and you have the air tube here, and you have a siphon or something coming out through here, what you can do is you could have just this as the operating tank and have a blocking fluid like oil or something like that, and have something like alcohol or whatever, some kind of refrigerant or expansive liquid here. You can even use water right here, and then you could let that heat up and cool down, by the sun, or when it gets cold, it contracts and stuff like that. And you just let this thing sit out in the sun, during the day and night, so that as the day progresses, it becomes hot, expands, and pushes out. And once the thing pushes out, pushes the oil up through here, and compresses the air, and then pushes the air up through here into this positive accumulator, or just wherever you want to run it to. And then when it gets cold, at nighttime or whatever, what'll happen is the refrigerant will compress and it'll pull the oil up into itself, kind of like it is right here. And what happened is that'll compress and it'll suck the air from this thing right here, from this negative tank here, or wherever. It'll suck the air in through here into itself. So through both daily temperature variations, as well as between the day and the night. In the midday you have temperature variations, and also during the daytime and nighttime, it's kind of you have some major variations going on at a slower rate. You can pump air or whatever you want to with this arrangement here. So you can use this as the operating tank to pump water or whatever you want to through a more thermal arrangement right here. So that's one thing you can do. Another thing you can do is you just have a plain tank without the oil or whatever. Just have a closed tank like this, filled with alcohol, ammonia, freon, any kind of refrigerant, something that expands. Inside of here, you can even use air or water, but it doesn't expand as much. And then what you can do is you can run a air tube to like a cylinder or something like that. That would mechanically, you can run this, when I say cylinder I mean like a piston or something. So what happens, it pushes on the piston, and you have on another you know, side of this thing, it can compress and expand as well. So this thing will compress and expand the cylinder without the refrigerant escaping. And you can power something like this, or you could power, you know, a basic hydronomat setup or whatever you want to with this thermal arrangement here. Or another thing that I found out just recently, which was kind of neat. This was actually my own little invention here after I was playing with some other stuff. Another thing I found out is you use what's called a Fluidyne, which is really neat. And a Fluidyne basically is like a liquid Stirling engine. And if you haven't seen a Stirling engine before, you know, I suggest you go look it up. It's basically a thermal powered engine. You know, it's just a little piston driven, a little heat driven piston engine or whatever. Yeah, or you could run the thing on top of like stoves and stuff like that. It doesn't give out much power, but you know, it's kind of interesting. But the Fluidyne is just a pure water version of that. So instead of having like wheels and pistons and stuff like that, like you have a normal Stirling engine, you just have air and water, or whatever you want to use. So basically, the way a Fluidyne works is, what you do is you have this whole arrangement here, and what you do is you have, you know, right about where the water, you know, meets the air or something like that. This right here is kind of a more heated up version, but right here around like around the water mark, you would heat a section of it up, and when you heat it up, what will happen is this will start to evaporate, you know, pressurize this whole area here, and what it'll do is it'll force the water down, you know, both here and here, and it'll force it out through here, right? Well, what happens is it eventually heats up. It keeps on evaporating to the point that the water level drops to about here, and then what will happen is that the amount of fluid that's being heated up and expanded starts to, you know, drop basically, right? Because it's not heating up the water anymore, or at least not directly heating it up so much. And the whole rest of this structure here will start to will start to be cooled by the air, right? Because the air is continuously exposed to here, and it's continuously cooling this heated area. And when it continues to cool it, it'll cause it to not expand, but it'll cause it to condense. And when it condenses, what will happen is all this gas here will start to turn back into liquid, and when it condenses, it also contracts. So what will happen is that this fluid here will start to rise again, and what happens is what would previously be dropping is now going to start to rise again, and when it rises, well, it's really pouring down outside. What will happen is it'll start to condense, and it'll pull the fluid inward. So what happens is you have this vacuum here is pulling this water up, and what it'll do is it'll actually be able to pull water, you know, from a basin or something like that up into the tube into itself as well, you know, right here. And when this thing, you know, starts to cool down, you know, to a point that the water starts to fill up this heated area again, what will happen is the heated area will start to boil off the water all over again, or boil off whatever fluid all over again, and the cycle start, you know, over. So what you have is you have an oscillation of this thing going down, you have it going up, so it pressurizes and you know, depressurizes, creates a vacuum or whatever. In the process, you have water being pushed out and also being replenished, so it, you know, sucks water in and pushes it back out, and you basically have an oscillating pump. You can also Google this device. It's called a Fluidyne. It's Fluidyne, Fluidyne. And you know, people have a lot of neat little devices out there using this device. But what I was thinking about doing was having something like this to you know, power the Hydrautomat. So you can kind of use, you either put like a piston here to kind of separate the flows. You know, separate this liquid here from this liquid here. You just have a cylinder going back and forth. Or what you could do is you could just have a kind of like the Hydrautomat, where you have, you know, an air tube separating two compressing, expanding, systems of water, something like that. So this is just another way of pumping water or some other fluid with heat and cold. And if anyone wants to know what these are actually check valves. It's 1 here and 2. These are just check valves. That's all these are. So it makes sure that the water goes up, it doesn't come back down, and just rectifies the flow while this here alternates. So that's for this segment here. Okay, now I'm going to go on to to another really interesting and very, very promising application of the Hydrautomat, and that is the ability for it to be able to actually pump water from a point that's actually lower than where the water is, is lower than the high and low water mark. So, say you have like a river or something like that, and you want to pump, a well or something like that, or at least a shallow well, or you want to pump from another water source or something like that. You can actually use a Hydrautomat to do that. This is kind of an experimental thing. I'm still playing with it right now. But you can actually, this is going to be this has actually been patented and whatever in a different patent. Not using a Hydrautomat, but actually using a tromp. It's using a combination of a tromp and an airlift pump, basically, as well as a siphon action or whatever. So anyway, I think I'll pause this video. I'll show you. Hold on a sec. Okay, so now I have the patent and everything all loaded up, and this thing looks like a serious Rube Goldberg deal, right? It really does. But this is actually a very interesting, actually relatively simple device. It's just the illustration is a living nightmare to try and figure out. So anyway, I'm going to explain how this thing works. Basically the Hydrautomat is the very same thing as that. This version here is pretty much the same thing as this, but a lot simpler. So anyway, you have say the high water mark right here. This would be the high point here, A or whatever, and here would be B, lowercase b, and this would be the low water mark, right? And what'll happen is you apparently this guy's got some valves and stuff, so you can just open it up without having to run the siphon, through here without having to suck on it or something. Right here, so you could basically open up this butterfly valve, start a sort of siphon action right here, and apparently the siphon, as this thing starts to flow down, it carries water, I guess, from this point here, as well as this air tube here or whatever, and maybe also from the outside or whatever. But as this thing carries water down with it, it acts as a tromp. And what a tromp is basically the very same thing. What happens is you have air and water go down a tube, and then have the water able to basically let the water flow out into a lower point. So you have it going from a high point to a low point, so you get that flow going by force of gravity. But the thing is that by buoyancy, what will happen is the water will actually carry the air down here, and the air will start to rise up and get trapped here in this little pocket. And what will happen is that the weight of the water here flowing actually still has some upward pressure and stuff. So what will happen is the water will actually resist the air and help pump it upward, up into here. And that's how a tromp works. That's what they used to use this for, compressing air to use in foundries and whatever, so you can blow air on the fire and make it burn hotter and whatever, for when they were melting steel and stuff back in like the 1600s or something. And this is how old this technology is. I think it's like a 16th century technology, so it might be I think it's 1500s or 1600s when they figured this out. Pretty ingenious device. But anyway, this thing also acts as a sort of an airlift pump, which is sort of a reverse of that, where you use the compressed air to pump the water up. So instead of using the air to instead of using the water to pump the air, you actually use the air to pump the water, is what an airlift pump is. So this is a combination of the two, and that airlift pump is actually right here. So what this is actually a tube. If you're wondering what this is a stopcock right here. This is a lever to manipulate this little valve here or whatever to turn it on and off and to regulate it. But anyway, all you need to know is that the air compresses up through here, and there's a bunch of openings in this tube. This tube that runs up and down here. There's a bunch of openings here for the air to inject into. And what the air will do is the air will help carry the water upward and pressurize itself more and more and push the water up. And as this water is being pushed up, the air is also being sucked up by this tube here, up through here. So as this water moves, through here in the siphon, and eventually, I guess, is able to climb or something like that. I've seen this in a few of this guy's patents, J.O. Boving, which later on, I think in the later in the 30s or 40s or something, he also had a patent in combination with Hydrautomat Limited, which was a company created by the inventor of the Hydrautomat, Thomas Gaskell Allen. So the company that Allen created, Boving eventually contributed to, I think. There's like, I forget what patent, but there's something by Boving later on. I think Hydrautomat Limited was listed in somewhere in the patent. So you could go look that up. But this is one of the earlier ones from 1928, which is after the Hydrautomat by like 6 years or whatever, or 7 years. But this thing's definitely different from the Hydrautomat. So anyway, as the siphon here goes down and whatever and pulls the air down, it also creates a suction because it's pulling the air out of here as well as here, because there's only a certain amount of air in here, and once it's done with that, it'll start pulling on this as well. Well, while the air's here, it's also pulling on this, and that suction alone will also help to raise the water up this tube as well. And this right here is probably like a venturi or whatever. This is a valve that you can open for the air to also go up into it. So it's kind of like a jet pump or something. I guess it's just extra air to help it if there's not enough air from this trompe as it's going up, or there's more suction than there is pressure. You can open this thing. I don't know. This is just an auxiliary secondary thing here. So basically, this thing's a hybrid of sucking it's kind of like the Hydrautomat where it sucks the air upward, and it also uses a trompe or whatever to compress the air into an airlift pump to push this water upward into here, so you can raise the water to a greater height. So that's how this device works here. Now going to the well pump, that's basically all I need to know in order to understand how this thing works. I actually developed this device came up with this idea here before I even saw this thing. So I took a bit of understanding, like, oh wait, this is just exactly how this thing works. So basically all you do with this, the Hydrautomat, is you have the operating tank. So basically forget all the other components of the Hydrautomat. Just say that where it says Hydrautomat here, this little block, just imagine that being the operating tank. That's all you need to know. And the operating tank, instead of the air tube being without check valves and allowing the air to both compress into the closed tank and also expand, be sucked out of the closed tank, imagine that there's only a check valve here. So basically we put a check valve here so it only allows the air to get sucked out, and you have a check valve on here that only allows the air to get pushed out through here. So in the operating tank's on its pressure cycle, it pushes out through here, and when it's on a suction cycle, it pulls up through here, right? Now it's pretty much the very same thing as that device, except it doesn't use a trompe, it uses an operating tank. That's the only difference between the two, as well as some little widgets and stuff. The guy's got all kinds of stuff on it. But anyway, that's that's the very same fundamental principle of it. So the operating tank compresses the air gets pushed down into an airlift pump. The air helps displace the weight of the water, pushes it upward, up through here. And when it's on the suction cycle, it pulls the air from this tank here upward into here. And the air, this vacuum here eventually gets replenished by the bubbles that come up here. So you have replenishment of the air in here. So it's not just sucking until it starts pumping water up into here. You also get the air eventually cycles back through into here. So you have a closed circuit, or at least hopefully in theory you have the same amount of air that's being conserved throughout this unit without being lost through the outlet here. So basically, when this thing's on a pressure cycle or whatever, when the air is pushing up through, I guess it, I haven't worked this thing all the way out. You might also need to have a bleed valve or something here. When I say bleed valve, I don't really mean a bleed valve. I mean, something that would cancel out the pressure between the suction cycle and the pressure cycle. So when one cycle is done, you can depressurize it, and then everything can flow out through this tube. and whatnot. Also, check valve on here would be good too. So I have like 3 other check valves should be on this thing. Sorry if I lost you folks. I'm just thinking here too. So anyway, when this thing pushes up and whatever through the air, it'll break the vacuum too, because the bubbles coming up through here will break the vacuum that was created in the previous cycle. And as the water fills up, the vacuum gets broken and they'll just flow out through here. So that's how you can use it as a pump or whatever. And the idea here is hopefully to use it for wells or whatever. Maybe not a deep well, but you could possibly use this as a well pump or something if the dimensions and stuff are right. So if you have a river or something nearby or whatever you have to power the Hydrautomat, even the thermal versions and stuff that I talked about. If you have something to power the Hydrautomat, with the dirty water or river water, which you've got to filter and stuff, stuff like that. If you have water that's not really trustworthy, or too hard or something, you can still use that water to pump, well water, which might be drinking quality, or a pump from a spring or something like that, something that's of higher quality drinking water up through here, and it doesn't even have to touch the dirty water. That's one thing that could be done. Or you could use a thermal arrangement, like a Fluidyne or a thermal, piston kind of thing, thermal based Hydrautomat to pump the air, pump this water up, and then you can get drinking water using a temperature differential. That's another way of pumping water, and that'd be really great for the world. Because if you had if you're in like an arid region or something like that, like over in Africa or whatever, and you got it's hot as hell, it's just really hot, and you have enough heat or something like that, you have enough sunlight, something of that nature. Or possibly you could use the cold, because the ground is always at a certain level beneath the earth. The earth is always at like a constant of 50 or 55 degrees Fahrenheit. And if the air is really cold outside, you could possibly use that temperature differential to make a pump out of it. And I was exploring that. I've been exploring that for some time now. I've been come up with a few devices. One's was overcomplicated and didn't work, but if you guys, if someone can figure that out, that'd be really great. If you could have a Hydrautomat or a thermal piston or something like that, some kind of device that can compress, that can pump air or whatever, some kind of fluid, by using cold and just the thermal energy from the ground. So you have a temperature differential that's powered more by the cold than it is by heat. Kind of a reverse of a Fluidyne or whatever, something like that. But anyway, just so out of the an arid region or something, you could possibly use something like this to pump some kind of fluid. So that's one neat little application of the Hydrautomat, or a Fluidyne or whatever. You could possibly use something like this, a combination of an airlift pump and a suction type pump. So that's it for this one. All right, now I'm going to get into sort of more futuristic concepts for the Hydrautomat. I say futuristic because they haven't really been worked out or developed very much right now. Haven't had time to work on it, and also I'm kind of inexperienced with things like Fluidics and logic gates and things of that nature. But one idea I had for it was to combine both the suction and the pressure of the Hydrautomat, most likely by taking the most likely by having 2 accumulator tanks. So you have one tank for pressure and one tank for suction, so you can store the energy that's built up by those two, and release it at a later time, so you can power something with it, because you can power things on suction as well as pressure. So to save up both the differentials there. So anyway, I was thinking about taking those two, storing them, and then releasing them, and it's kind of an alternating manner, kind of, like a sine wave, So on the positive, wave or whatever, positive end of the wave, you have positive pressure, and they would, start to trail off, and then go into sort of a negative pressure, on the other end of the wave, something like that. So you have an alternation between push and pull. So it just constantly does this, at a higher rate than just at the rate that the Hydrautomat would normally do it at. So you can store the energy up and then release it at whatever frequency you want to release it at. And that way you could use the Hydrautomat as a generator for pulse pneumatic energy. So that push and pull can be used for all kinds of different applications. And one application I was definitely looking at was something called a sonic wave pump. But first, I might as well get hit on this stuff first here. These are the potential circuits for achieving an oscillation like that, an alternating oscillation. This right here is called a fluidic amplifier, which basically is a circuit. It's a arrangement that's designed to amplify. That's designed to act as a sort of amplifier, like you have like electronic amplifier, except it runs on water or air or something like that. So basically, the way this thing works is you have a power current or something like that. You have the wire going through as sort of the power stroke. The main power of the amplifier going in through this way right here. And you don't necessarily need this thing here at the end. I guess in this version they do have it. This is an older patent, whatever. You can just have this thing going straight up into here or here. But what you also have here on the ends, this is kind of like the grid of a amplifier or the gate or something like that. I forget what it's called. I think it's called a gate or something in electronics. No, heck if I knew. But anyway, this basically acts as a control. So what happens is you can determine which way the flow goes based on which, one of these tubes you put pressure on, right? So as this stuff is going in here, if you put pressure on this control tube here, what happens is the pressure is going to push it this way, and it's going to go in like this, come in here, create a sort of Coanda effect or whatever. This is optional. You don't even need this right here. You can just have a straight, V going through here. Some of the more modern patents I've seen. And anyway, you would push this in here. The stream would be pushed. When you have a pressure on here, the stream gets pushed off to the left, right? And when it gets pushed off to the left, it goes into the left tube, right? And then when you if you had this off here, and you pushed, if you put pressure on this right here, on the other hand, what would happen is you would have the stream get diverted in this direction here. So the stream would get pushed off into this way, right here. My mouse is being squirrely. So if you put pressure on here, the stream's going to go off to here. If you put pressure on here, the stream's going to go off to here. That's basically all a fluidic amplifier is. It's an amplifier, or a switch, whatever you want to call it. And back in the 70s, they were actually building like computers with these things, but electronics eventually won out. So there's this device right here as an amplifier, and this was eventually modified so that this tube here would actually connect to here. You would have this tube actually this tube here would go off to wherever, but there would also be a secondary tube that would feed back into here, and that would become your control. So part of that pressure would also be diverted into here, and it would cause this thing to go into oscillation because you also have another tube going into here, like you see with this fluidic oscillator. Now the way this thing works is it's very much the same as fluidic amplifier, except the fluid will go in through here, and instead of having the control be controlled by something else, it's controlled by itself. So some of it will go off to one end here, and then part of that will go off and become the control, and then the stream would get diverted from here to here, because this would be pushing on the stream, and the stream would be pushed up into here. Then part of that would come back around again, and then divert the stream back to here, and it would just oscillate rapidly back and forth between these two. There's a few other different types of fluidic oscillator, but this is probably one of the most elementary and most fundamental ones for you to see. This is a very simple thing here. So that's how this thing works. It's kind of an oscillator arrangement. Yeah. Oh, yeah. Okay. Flip this thing around so you can kind of so it looks similar to this here. Anyway, that's kind of what I was thinking about doing, or possibly use like a use these amplifiers some way to create like a flip flop switch, or do something with it. I'm not exactly sure yet of just exactly how to do it, but you can also use suction too. So if you wanted this thing to go like this without putting pressure on here, you could have suction on here and it would pull the stream toward you. I mean, not toward you, but toward the suction or whatever, and it goes very same way as well. So you could use suction or pressure with this device too. So I was thinking about combining like two amplifiers a certain way, or just to do something in order to get the oscillating wave to work. And in addition to all different pneumatic things you can do with it, the one thing that really stands out is this device here, which is a sonic wave pump. And normally the way this thing works is that you would have a engine or whatever turn this shaft. You have it on a crankshaft, and what would happen is the engine would cause this piston to oscillate up and down, back, just upward and downward or whatever. And at this, this thing would be drilled into, you would drill a well, run this tube down here, this would become the well. And right here at the end, this little ball here, marked V or whatever, would be your check valve. And what would happen is that when this thing would go down, it would pull the water up past this check valve here a certain distance. And then what happens is when it would go back up again, what it would do is it would pressurize the air, and then push some of the air up, and also it kind of start a pressure wave down here too. So it compress the water and close the check valve. And what would happen is, I guess, it kind of makes a sort of elastic. It's kind of like charging a spring a little bit, so that when this thing re-expands outward, the water is going to go along with it, I guess. So it's going to go for the ride instead of just the water being raised from an inertial level like this. Is actually compressed and already wants to expand, and when the pressure is released, it already does that. And then when it goes from no pressure to a vacuum, then it would suck the water up even more. So you can kind of create a sort of waveform inside this tube here. And the idea of this device was to create a standing wave, to tune this whole thing so you make a standing wave, and apparently that pumps the water more efficiently or something like that. This is really an interesting device from the 1930s. It's by Torribo Bolok or whatever. There we go. And it's a really interesting thing. So you have kind of a sine wave or something here that's created by the piston going up and down. And he was able to tweak this thing in many different arrangements. I'm going to show you right here. We would actually create his own. No, I don't want him to do that. There we go. What he would do, also, to help tune the tube or whatever, so you would have a sort of wave generator here with this piston. What he would also do is you would have different things like, this would be like a capacitor. This inertial thing would be kind of like a resistor or whatever. Like he said, I think he said inductor or some damn thing. I don't know. This right here is basically a blockage or whatever. So this is basically a resistor. This is a capacitor. This here's another type of capacitor with sort of vibrating diaphragm in the patent. He didn't recommend using this. This was just for to give people an idea. I don't know. This was another type of capacitor here off to the side instead of being in line. It's off to the side. And this is another one with a spring or whatever. And this is the check valve here at the bottom. And this right here is kind of a parallel, I think it's called a parallel tank circuit. Basically is what this is. It's an inline tank circuit with a capacitor and a resistor here. And this is another capacitor off to the side. And basically he'd be able to tune the well to a standing wave with this wave generator. It's really interesting stuff. How this guy came up with all this stuff in the 30s, you gotta give it credit to him, especially when you see this. Right here, hold on. Oh my God. There we go. Okay, I don't want to zoom in too much because I'll miss part of the content here. So anyway, he took all these components that he developed, he studied electronics a little bit and made different analogs to these electronic components. So this right here, if you're wondering what this is, for anybody that's kind of knows about electronics but doesn't know about the older stuff, this right here is a capacitor, or it was actually called a condenser back in the day. You'll see these in Tesla's patents too. He calls them condensers. And this right here, this little squirrely thing here, this is an inductor. And I guess this is his analog to that. This is the pneumatic analog to that. And apparently he created different filters and stuff. So he had like these, was it like shortwave filters and long wave filters, and he had like bandpass filters or something like that. Like he had a bandpass. There's a bandpass filter in here somewhere. I'm not electronically inclined very much, so he had. Oh, man, it's wild. This is more of a resistor, not an inductor. I don't know how he came across that one. I guess he figured that since the inductance helps to slow it down, that it does that. But this is more or less a resistor. Whatever. But he created different filters and stuff for this thing, so it would operate at certain frequencies. Or it's wild, But my hopes is to possibly use the sonic wave pump principle, because you could pump deep wells with this thing. The application of this device is that since you're using pulsed power instead of just steady power, instead of just having a steady pressure on the thing, you have the pulsations or whatever, that actually allows you to do more work with less energy expended to it, less power. I'm kind of rusty on my physics, but with the same amount of power from this engine or whatever, you could actually pump more water with a pulsed arrangement than you can with a normal conventional well pump, where it just tries to suck the stuff up and tries to fight the weight of the water pulling down, because when the water gets sucked up, there's also the force of gravity resisting it. And with a normal pump, it just tries to strong arm it and force it all the way up and fight the force of gravity. And with this device, what it does, it uses a sort of shock wave to get kind of entrain the stuff, so that the pulsations can do even more work than a normal thing can. And this thing's usually used for deep wells. You can actually pump from deep wells at a fraction of the horsepower that you can pump from deep wells with a engine that's only a fraction of the horsepower that you would normally need to pump from a deep well. And that's the amazing power of this device, is that you can pump from a deep well with this device with a smaller engine, or a smaller prime mover than you would normally need with a conventional setup. So that thing is very powerful in itself. There's a more advanced version of this by someone called Bodine, which is different from Boving, I think. Yeah, different from Boving. And the guy's got this thing right here, which is, these are springs or whatever, and this is some kind of like vibrator or something like that. And I guess it's kind of like a diaphragm. No, it's not like a diaphragm pump. What this thing does is it has this whole shaft and check valve assembly and stuff. It basically has like this column, I guess, that I haven't read the patent very much, but from the looks of it, basically this thing oscillates up and down and creates shock waves inside this tube here, and helps and basically shock waves entrain the water and help suck the water up, so you can actually pump water from very deep wells with not anywhere close to the amount, not anywhere close to the size pump. You don't need a pump that's anywhere near as powerful as you would with a conventional arrangement, as you would with something like this, where it uses shock waves instead of trying to just strong arm the just trying to really force the water all the way up. You just use shock waves to help the thing along the way. So that's what this thing does, and this is used for really deep. This is actually used for deep well pumps. The guy had a few of these things on here. Under the, you can find that also here on this Rex Research page for Taribo Belok's wave pump. You can find that right here. by Albert G. Bodine. Here's the one from '48. Here's the one that you just saw from 1951. Here's another one, and I guess he has like these compressible compression fittings or something. Yeah, it's like compression fittings and stuff, and it kind of sandwiches them, and they kind of have. I guess these are check valves, these round things, and these donut or whatever shaped compression fittings is what I think that is. Maybe I'm wrong when I say compression fitting, but this is designed to compress, and that's kind of to help to store the water or whatever. So that's how this thing works. And there's several different improvements and stuff this guy made. And there's Bentley, some other inventor. But yeah, that's what I was kind of hoping to do, was to take the fluidic amplifiers and stuff, string them together so I make kind of a inverter where I could take the positive pressure and the negative pressure, run it through this sort of flip-flop switch or sine generator, pneumatic sine generator, and then use it in a shockwave pump so that you can actually use the hydronomat, depending on you have to get the pressure up there or whatever, but you could use a sort of pneumatic shockwave generator to pump water from greater depths, or or pump it to greater heights, whatever you want to do. Pump it from the bottom of a hill to the top of the hill, or from from the ground from the ground pump the water from a aquifer or something like that to the top of the well. Whatever you want to do with it, you can do with this device. That's the theory I have for the Hydrautomat, is to possibly use that as well as air injection and stuff as well. Like you see with the deep well pump and stuff I talked about. So combine all those things together, you could have a pretty deep well pump, or you could possibly create a deep well pump with only that would operate on only the fraction of the pressure needed. So that's a neat idea that also presents itself. Okay, so I hope you liked the whole video and stuff. Hope you like the different sections and things like that. For anybody that's thinking themselves, anybody's thinking that you could possibly take this as kind of a blueprint or something and put into action. Just one disclaimer: these are all ideas. Maybe not all of them are ideas. The Hydrautomat itself, like the mini-mat and stuff, all the ones you see in my videos, those have been developed by me personally. I have worked those out. Those do work and stuff. But all the stuff you've seen here, like this solar gradient pond, I'm gonna have to hold on a sec. This is Noir. Sorry, folks. New operating system, so it wants to open in a editor instead of a viewer. Anyway, stuff like this here is really an idea. This isn't a worked out system here, so this kind of flowchart, sort of looking, not a flowchart, but this whole diagram of an entire system here. This isn't actually. You shouldn't take it. You should take it with a grain of salt, because it's not. It's not an actual blueprint. So you can't just take this thing, hook it up, use this as a blueprint, and then expect it to run. And more than likely, it probably won't, because there's no control systems or anything on this really. So that's one problem. And two, this is an idea. So for everybody out there, all these are ideas and stuff, and I'm putting this video out here so that you can look into this stuff and develop it, or either preferably you or somebody develops it, or send this off to like a non-governmental organization, also called an NGO. Maybe Engineers Without Borders. I'm going to contact probably one of the local ones out here, just to tell them about this and run it past them and stuff. But show this to somebody you think might want to look into this. Someone you think might be in need. Anything like that would be really nice to do, because a lot of this technology is very simple. I mean, this does look complicated, I have to admit, but it's all very doable. It's all very simple technology. The only thing I could think of that's really sophisticated or kind of difficult to get your hands on is this little turbine here. You know, because steam turbine, refrigerant turbine, I don't know where to get those. You can't go to Lowe's or something to get one. But, you know, short of something like this, you can do, I mean, you could probably come with a replacement or something maybe. I don't know. But anyway, you know, the point is that this stuff basically serves as an idea. So, you know, you kind of get the basic concepts and stuff worked out of, well, can this work? Well, yeah, potentially, yes, it can work. And, you know, this part here and stuff has definitely been worked out, with the exception of the operating tank working in a coastal environment. That does need to be tweaked and worked out, you know, especially with the tides and stuff. As the tides go up and down, you need to adjust for this thing and stuff. So, like I said, it needs to be developed, but this is a great starting point here. This does give you an idea of where to, you know, of what to start with. It does give you some extra ideas to add on to anything that anyone is already working on. There's all kinds of different stuff out there. You know, stuff like, oh my God. Hold on a second. I'm going to pause this and we're going to be right back. Okay, yep, alright, now we're recording stuff. Yeah, sorry about that. I had to change the defaults from GIMP to View Noir. And the only difference is that this is for viewing and stuff, so I can zoom in with it, and GIMP is for actually making the pictures and stuff. Anyway, you know, things like this right here, obviously it's not been worked out, except for this part right here. This has been worked out. As you can see, you know, as you can see with my older, you just go on my YouTube channel and look at the you know, the different Hydrautomat videos and stuff. You'll see these things in operation. You see them all working and stuff. You know, except for that older one, that was, you know, kind of I was in the process of doing things, but you know, this stuff does work. You know, I think this is, yeah, this is like normal Hydrautomat, where you have an open tank, a closed tank, another closed tank, another open tank. You know, this part has been worked out, but the secondary thing here with the extra operating tank and a piston or whatever, I haven't bought one of these yet, but I do want to get one of these and experiment with it. That'd be pretty fun. So I'm going to want to get one of these pneumatic cylinders and maybe experiment with that, and you know, maybe play around with this pumping tank thing and stuff like that. But you know, for me personally, it's all, you know, time, money, and labor. You know, and that does limit me to quite a few, you know, to only a few things, especially when you're taking engineering in college and stuff. And calculus is coming up. Right now it's June 13th. It's coming up on July 1st. So I also have to be studying in addition to making YouTube videos. And that puts me in a tight spot. Even though I would love to do this stuff, don't get me wrong, I most definitely want to do this stuff because it does help the world. It makes the world a better place, and that's kind of my mission, is to do stuff like that. But in the meantime, I do hope someone out there can take these devices. This is all, I combined two words here together, sorry. This is all OSATs. Alright, and an OSAT is an acronym for Open Source Appropriate Technology. So in other words, all this stuff here, I'm not going to patent. You know, of course, this has already been patented. Oh my God, it's still... Okay, it's because it's a GIF, it's opening it up in GIMP. Anyway, you know, this stuff has been patented and stuff, you know, long ago. It's in the public domain now. Oh my God. Anyway, sorry, it's just the editor. You know, yes, View Noir. You know, this stuff has been, you know, all done and stuff like that. But, you know, these ideas here, okay, the PNGs work for View Noir, I don't know. Anyway, this is a new operating system, so I got to tweak it. But anyway, you know, this kind of ideas and whatever, I don't want to patent these because I want them to be in the public domain. You know, maybe I could get a protection to make sure that nobody else patents it, says it's mine, stay away from it, you know, kind of things. I don't want somebody just to patent it, say it's my, you know, property, I invented first, blah, 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 and now the whole world can't use it. I would hate that. I really would. And but anyway, you know, I want to release all this stuff here, all these ideas for people to take to build on and to develop. You know, if you gotta modify it, I don't care. I mean, this is just all ideas and stuff. So these are going to have to be modified very certainly. But you know, to take ideas like this, I'm going to get into this, by the way, in another video. If you're wondering, you know, what is this thing? This is a well pump, basically. So you use that desert piston or thermal piston, whatever your, you know, it is. Yeah, I'm just making the names up. You know, give it a whatever. So basically, use a thermal piston here, and this powers, you know, a hydrotomat that's embedded in a well, so it can just carry the water up level by level. So if you don't have enough pressure and suction in this you know, generator here to pump the water from this point here to this point here, but you have enough to power from here to here, say, then you can eventually make it up. You know, something like this. I'm going to get to this in another video, but for right now, this is another potential application. So anyway, the whole point of this thing is I hope you take these ideas. I hope you or someone else develops them and stuff, and helps make the world a better place. I'd really love to see that. And you know, do share and like this video. Namely, share it. You know, and also do like it. You know, keep the trolls at bay. I'm every once in a while, I guess some drunken nut that shows up on New Year's and dislikes my videos, or like the actual drum circle thing. Someone said they don't like the drum circle, and they just dislike my video. I don't know. Whatever. But you know, so do that. You know, please do share it. Most of all, I mean, make your own. If you don't like me for whatever reason, I don't care. You know, just now if you do like this stuff but you don't like me, you know, I'm just saying. What I'm basically trying to say is that if you don't want to like forward, you know, my stuff or whatever, that's fine. Just, you know, take this information, make your own video, and share it to the rest of the world. All I care is that this stuff that I'm like pointing to a screen here, but you can't see what I'm doing. Okay, yeah, here with my pointer. As you can see right here with all this stuff, all I care is that you take this information and you share it with the world. That's all I really want you to do. That's all I want. Really, all I want to see you do is take this out there and help people, because I would really love to see that. And you know, hopefully stuff like this can help alleviate the world water crisis, and over time, I can't say get rid of it, but you know, I would certainly want to see this stuff or anything else related, you know, not even related to it. It could be something completely different, totally different widget, you know, totally different device, as long as there's something out there that can stop the drought and also the famine, which is, you know, lack of food and stuff, which you know, experience in farming, seeing as we throw out 2/3 or more of all the food that we grow in farms because it isn't fit to sell on the market, because people don't like, you know, a pepper, for example, if it has a blemish on it, and that stuff just gets thrown out, just gets left out in the field to rot. So there's one helpful hint there for stopping the famine that's out there too, is because a lot of the food just gets thrown out, literally, not just at the dinner table, you know, that people don't finish their plate, but before it even gets there, a lot of it gets thrown out. It was incredible. You know, I mean, even potatoes get thrown out. Yeah, it's terrible. You know, just because of cosmetic problems. I mean, it could be a mutant, it could be totally edible and nutritious, but just because it doesn't look like the perfect potato you see on the bag or something, they just chuck it back in the field. It's sad, but you know, anyway, for this crisis, the world water crisis, is what I'm kind of trying to gear this one toward. All these devices. Yeah, you know, do show this stuff, and yeah. So I hope you like this video. You know, as I said before, do share and like. You know, comment on it too. You know, ask for any, you know, if you have any advice, or not advice. If you want any advice, or, you know, ask me any questions about this stuff, anything like that. If there's any sources that I haven't listed, I think I have listed them. At least the stuff that's on here on this pictures on this, when you're in this little folder or whatever. But if if you have any more questions and stuff, feel free to ask me and stuff. That's fine. And yeah, so I hope you like this. Yeah, just looking at Fluidics here. Okay, so stay tuned.